Hello, everyone, and welcome to today's session. My name is Tanya, and I will be your host. Today, we're joined by two industry leaders who bring hands-on experience from both sides of the design to manufacturing equation. We've got Nick Coubray, who is the CEO of Howick. He leads the company's global innovation efforts. A third-generation Coubray, he began his career on the shop floor and has since helped grow Howick's presence worldwide, bringing deep insight into framing technology, CNC manufacturing, and collaborative R&D. Joining him is Brandon Ionata, who leads Great Tech's Fabricate product line. With deep expertise in BIM, CAD/CAM, Revit customization, and cloud-based workflows, Brandon helps customers bridge the gap between digital design and real-world manufacturing. Together, Nick and Brandon offer a unique perspective on how integrated digital workflows and manufacturing technology are transforming the future of industrialized construction. Now, just before we get started, I have a couple of housekeeping items. We do have a Q&A section on the side of the screen if you have any questions. Please feel free to type them in, and either Nick or Brandon will get back to you in the next coming days. All right, that is it for me. I will pass over to Nick and Brandon now.
Thanks, Tanya. Hey, Nick, how are you doing?
Yeah, good, thanks.
Awesome. So I should probably mention that Nick and I have known each other for, what, 15 years now, almost?
Yeah, at least. It's been an interesting journey.
Yeah. I don't know if that's a glowing, but no, yeah, we've known each other for 15 years. A lot of trade shows and a lot of customers. So really happy to have this conversation with you today. And I think before we jump into the bigger kind of industry conversation, it would be great to set a bit of the context. Not everybody knows who Howick is, at least not as well as I do. So can you share with us a little bit, what Howick is, what they do, or what your company does, and how your machines play a role in the offsite and prefab industry today?
Yeah, so we're based out of New Zealand. We're a family business. We've been around for 48 years now, building all sorts of roll forming machines, but predominantly for the construction industry. So we started off with the light gauge stud sort of pieces for house builders and commercial fit outs, and then into the really heavy modular stuff as well. So we've been doing all sorts of weird and wonderful things, but a lot of it is around the framing, and again, then becoming prefab. And sort of what you're seeing in the market now is the market's caught up to the idea we thought it would catch up to 25 years ago, but it's certainly not been an easy road, and there's a lot of things people have to learn to make it successful.
Nice. So how many people are you globally?
So we've got, in the main Howick business, there's about 55 people, and that scatters out to, we've got machines in 85 countries now. And some of them obviously only one machine per country, but kind of US, Europe, Australia, New Zealand are our big core markets.
Nice. So you mentioned very quickly, maybe a little bit under your breath, that you've done some weird and wonderful machines. Now, I've had the privilege of hearing about some of these weird and wonderful machines. Care to share?
Yeah, so outside of the construction industry, we've done things for making ice cream, for skinning sheep, we did one for making potatoes for a chef that was really cool. It was take a big potato and turn it into a little fondant potato and turn all the waste products into chips. So we've got a good sort of thought process around manufacturing and processes of making things, not just construction. And I think that's quite an advantage to us, because we can sit back and look at something and say, okay, here's a crazy idea. Why don't we try this and see if this fixes your problem, without being straight down the kind of construction rules based. We can find a solution and then find out how to make it fit the rules.
Sure, yeah. Interesting. Sheep skinning to cold form steel.
Yeah.
That's quite the journey.
It's the whole New Zealand number 8 wire kind of thing. We're so far away, someone has to do it locally.
Right. Got it. So back to, the industry, construction industry. What kind of projects are you seeing most right now? How's the industry evolving?
So it's a little bit mixed at the moment. Obviously, it's been through a bit of a downturn and a bit of uncertainty, but The modular side seems to be fairly strong. Residential's pretty slow. Like our existing customers, the bigger guys are all busy, but the modular space, there's a lot of development going along, a lot of new entrants, and a lot of people that have sort of come from traditional build wanting to look more modular and prefab.
Hmm. Hmm. Um, all right. Well, I mean, you guys have been in the cold form steel space for decades, obviously. Have you seen a real shift in customer expectations?
Yeah, definitely. When we started, everyone just wanted a straight stud, fairly simple.
Yeah.
Now we're getting into a lot more complex things. The engineering's getting a lot more complex, probably in some cases over complex.
Yeah.
But the expectation is that, we can do anything and everything with one or two machines, which is actually a bit of a hindrance to people because they compromise for the 1 or 2% instead of the 80%, which is where the real value lies. So no, there's still that place for stuff that's not automated and not coming off a line to make the project work nicer.
Yeah, we tend to see a lot of people kind of trying to reinvent the wheel in a lot of cases, right? To add
Yeah,
their flair to it or their secret sauce. I don't know
exactly.
what your feelings are on that. I have a few.
Yeah, it's kind of some things are good to do, and some things are actually, while they sound like a good idea, actually just end up costing and slowing the whole process down. And I guess you guys see it too from the BIM side, the amount of information and data people want. How's that changed for you?
Uh, I mean, it's quite interesting because honestly, it's grown exponentially. People aren't just looking at their manufacturing data anymore. We're trying to, measure labor and that sort of thing, which is tough because it's not something that's, tracked so easily through a computer. So it's these are interesting problems to solve. We do still get a lot of those customers that try to reinvent the wheel. They want to, connect things differently, which, from a process standpoint, may not be the wisest, but it's not necessarily our business to, you know, tell people what to do. So if clients want to take that leap, we're happy to follow them down that rabbit hole. Um, so, I mean, on that topic, what is one of the most common mistakes you're seeing from new companies entering the offsite space?
Yeah, a lot of it is kind of trying to do too much too quickly.
Yeah,
We always try to promote a bit of kind of slowly approach to you know, automate the bits or change out your stud and track for a panelized system piece by piece. Do
mm,
the bits that are easy. The biggest problem we get is we pick up some customers who are going from zero to a 14-story building on day one,
yeah,
um, which is great. There's a lot of repetitivity in it, but you still have the same issue if you have to get it right. And it's those little details are the bits that cost you, especially with offsite. If it's not right, it's wrong, and then fixing it is a big problem.
right.
And again, it's the things of optimization as well. We see people come in and they're new to it or they think this is going to be a magic bullet, and we optimize and we're going to use 15 different sections and 10 different material thicknesses. The cost savings are not really there because what you save in material, you put it in labor. So that's probably the biggest pitfall we see. Now, I've been into one factory where they were using a 3.5 inch stud in 9 different thicknesses in the same wall. It's great. You're saving a bit of steel, but your labor cost, that panel's gone from a 15-minute assemble to a 2-hour assemble. So you've actually cost yourself money. And I think that's a pitfall people can't see because in a spreadsheet, it looks great.
Yeah, yeah, absolutely. It's crazy. I mean, the software in most cases, and not just our software, but a lot of softwares will allow you to do it, right? Just because
Yeah,
you can do it doesn't mean that you should do it. I
yeah,
think that's probably a mistake that we see all of the time, and I think going too fast is probably, as you mentioned, a huge issue. You see a lot of companies that are looking to, run before they could even crawl,
yeah,
start with a simple stud wall before trying to deliver a completely closed or even a volumetric unit, right?
yeah,
Work
yeah. And
that process.
we see the same with the bus pod guys that have come from a hot rolled section system, which is all welded.
Right.
It sort of is a like for like swap, but it's not because there's intricacies. So it takes them sort of 10 iterations until they get there. So again, that big mistake is I've built one, it looks okay. I'm now going to build 1,000 of them.
Hmm.
So, and I guess that's the beauty of how we work. You know, in the software, you can change that straight away and you can iterate and build a version 2 straight after version 1. Same with the machines. You just give them the file, make the bits. So you have that opportunity. You just have to not commit to a big volume like you would traditionally if you were getting hot rolled steel cut. You know, you generally will commit to 50 units to get a price break. You don't have to do that.
Right. Interesting. So, I mean, clearly you think standardization is a competitive advantage, in this type of construction. What about productization? That's a kind of you know, a big word these days. A lot of people pushing towards productization. Do you think it has a future?
Yeah, and it does, and it's a matter of those modules or those prefab units are made up of a whole lot of products.
Hmm.
So again, it doesn't make sense to redesign everything every single time. And there's certain elements that no one really sees them once they're inside the building, so they can be really standardized down to a product, like a hot water cupboard and things like that. They've got to hold the equipment, and they've
Hmm.
got to be a little bit of flexible of what equipment you can mount on them. But at the end of the day, it's a box. I saw a really good one the other day where they were actually pre-manufacturing wardrobes and closets for houses. Now they give up a little bit of space in the building for prefabricating it, but all that piece of all the hangers and all the shelves and everything can be done off-site and then just bought in. And these guys are building like a traditional style panelized building. They can bring those in and just drop them in place. And the cost of then not having to come in and paint those closets and fit out all the insides is a huge saving to them. So it's that balance of, how much floor space do you want to give up to save a bit of time,
Yeah.
take all that labor off, and a closet is a closet. It's a certain size. It's got certain things in it. It shouldn't really change unless you're building a custom home.
Yeah. No, that's it. I think the balance is key. I think that's what's kind of missed by a lot of companies. I've seen a lot of companies that are trying to productize, the structural elements of a wall panel, where, they have a specific number of panels that are all going to be made exactly this way. Whereas, I think that's a little bit difficult, especially when architects and building owners are looking to build, unique buildings or at least the semblance of unique buildings. I think that's a little bit difficult to do,
Yeah.
build it from a true kit of parts. But I think if you start looking at productization, and digging deeper into like the sub-assembly category where you have things that are highly repeatable, window openings, door openings, that sort of thing, these should all be the same across your building, given the structural differences. So,
Yeah.
um,
Well,
yeah.
it's the same thing. As a part of your workflow, you can build in all of those tie-down brackets and header brackets and those standard elements that you use. They can be automatically placed. And I guess that sort of leads us to the next point of the workflow. If you've got those standard pieces, how do you build that into a workflow for a standard building or a more customized building?
Yeah, I mean, it's interesting. I think that there you do need to. So one thing, if I just back up a little bit, that a lot of people don't understand is that your design needs to be, your design intent needs to be there for manufacturing, right? You cannot necessarily manufacture. I don't believe you can. I mean, you could manufacture everything, but you cannot manufacture everything efficiently, right? I think you need to design for manufacturing. So you have this whole DFMA process and topic to decide to discuss. But clearly, I think certain constraints need to be put around the design. And there's still a lot of variability when you start looking at constraints of products, such as tie downs and things like that. Over engineering something, may save you, like you mentioned a little bit earlier, may save you money downstream, right? So even if you're building with a heavier gauge in your wall panel, there's probably a lot of savings there, not having to switch gauge and material over and over and over again. And that's one example. There's probably thousands of examples that we could sit here and come up with, on that, whether it be, hangers or tie downs or so on. We don't always have to use the most efficient material. We can over engineer it and just use the same material.
Yeah, totally agree with that.
Yeah. Um, So when data hits manufacturing, I mean, what tells you immediately that the project is ready for manufacturing, or if it's not ready for manufacturing? Do you see any clues when that model or that model data comes to the factory?
Yeah, and it's one of the things we sort of see a little bit, and that gets forgotten, and that's where we run into problems with people where they say, "Oh, the computer spat out this thing, and now the machine won't make it properly, or it's got too many holes in it," or a common one is jamming. You've got a stud pack of 10 studs where you've done that on that efficiency side to say, I'm using all my cold rolled steel, where actually you could have put a post in there and it's not really an issue. So once you've done enough, you kind of get a visual look at it. We can see it. The problem is most people don't really look until something goes wrong.
Yeah,
And that's, I don't know how you fix that. Like the 3D models are great and you can generally spin them around. And once you've done it for a year or so, you can look at that and say, oh, I can see a problem there. Now, simple things like service holes missing or they're the ones that really cost you later. But the
yeah,
biggest one was roll forming, and it doesn't matter whose machine you're looking at. If you put too many holes in it, it becomes a bit like Swiss cheese, and it's going to jam or it's going to bend when you try and assemble it. Um, there's lots of little things there. There are some construction tolerances you have to allow for. We're accurate to half a millimeter or like a 32nd of an inch, but it's still a tolerance you've got to deal with.
of course. Yeah, and it's a tolerance you have to build into your project too, right?
Yep.
Because we see that all the time. You see, you get a very pretty Revit model on the outside, and then you look at the tolerances within the Revit model. They're not anywhere near where they should be for manufacturing. So
Yeah.
this has to start, quite early downstream, or you're looking at rework, right?
And
Uh,
and you've got to have that assemblability kind of thought as well. Like you can draw stuff that you can't assemble quite easily, and that comes with experience. And I think that's again is that magic bullet thing. People think I get a bit of software, I get a piece of machinery, and I'll start banging out panels. And to a certain degree, yes. But when you get into complex stuff, especially when you start to get into fire breaks and panels joining to panels for structural elements, you got to think, yeah, okay, I've got to get 10 screws into that corner joint. I can't actually access them. So that experience helps. So we know historically, we've got to put some service holes in to allow you to get a drill bit through 3 studs to screw the fourth one. Um, and that can be baked into the software, but you've got to know about it.
of
And
course.
a lot of people don't think about it until they're putting that building up, and it's a problem.
Yeah, exactly. Exactly. So we're talking a lot about kind of the stuff that's very repeatable, that's quite scalable, and we'll come back to that whole scalability thing afterwards. I want to talk a little bit about the way you guys have kind of approached some of the very one-off things, the curves, the really strange shapes. Because I see your guys, at trade shows all the time, and I've seen what the Eiffel Tower, the Autodesk A. I've seen some. I know you do a Christmas thing with light gauge steel sleigh and reindeer every year and that sort of thing. I mean, how do you make a machine go from a rectangular wall to something like that? What's the thought process there?
Yeah, so the machine's effectively a tool. It'll only do what you tell it. So drawing some of those things is probably one of the biggest challenges, and it comes to a lot of trial and error. So we will actually hand code a bit of stuff because the machines operate off a CSV and it's human readable, and that's a decision we made a long time ago to make them easy to operate. We can start tweaking stuff and we can draw something that's about right and then start playing with offsets and make things curve by combining a whole series of punches. And a lot of that has also come from a customer saying, can you do it? And so, well, we can't see why we can't, but what is its application? Is it structural? Is it non-structural? Can we put something else in it to make it work? And that sort of leads us a little bit to the telescopic machines we made. So perfectly for infill and existing projects, or we've done a lot at the moment. Actually, we've got 3 projects in New Zealand that are big CLT mass timber buildings with internal steel fit out. You don't see any of the steel; it's all hidden behind the backgrounds. But again, you were dealing with 2 different products, 2 different construction tolerances, and it makes sense. The bits you don't see don't need to be heavy because they're offices and bits and pieces. There's no point in doing those out of CLT just from a cost and weight perspective.
Yeah.
Um, So that was again driven by a customer. He came in and he wanted a sliding stud so that he could work with buildings that had concrete floors that were 6 inches out of position of where they were supposed to be. And we took that and said, okay, we can do a stud. Why can't we do a panel? Which led to why can't we do windows and door openings that are flexible? Which led to some of those funky curved shapes. Um, and that's the thing we've got to look at is that flexibility for things. Now, the biggest challenge is you can draw it and it will be 100% perfect. Then a guy gets to site and the concrete's not laid up properly, or the beam's in the wrong place, or services are in the wrong place. The traditional steel frame has zero flexibility. So you fire on site, which is horrible, or you redraw the whole thing and make the panel. Now, we did that experiment with Autodesk years ago up in Boston with the tech center, where we
Yeah.
built out the offices upstairs. And even if you go and 3D laser scan the whole building, something changes in the time between when you did the scan and when you roll the product. So that's not really a good solution because it's so time heavy.
Yep.
So the ability to have the flexibility is what sort of helps. And obviously you guys have worked with us on that and built it into the software so we can apply sort of a 10% tolerance for stretching those panels up and down to fit in the building.
Yeah.
So that's hugely successful in the time savings for on site. Like the guys we're working with in New Zealand can save up to 60% of install time on an apartment block, which is huge.
Yeah, it's a good example of, sometimes a little extra material may save you a lot of time downstream as far
Yeah.
as, labor and rework costs and that sort of thing. So yeah, it was an interesting project and really kind of eye-opening to how that variance can really affect construction timelines.
Yeah. And it's that whole thing with construction. It's always been a bit of a bugbear for us is everybody pushes it onto the next guy. Concrete slab's not right, so then the wall frame's not right, so then the kitchen doesn't fit. And it's always the next guy's problem. And I think that's one of the big kind of downfalls of the industry. It doesn't matter what you're building with. It's kind of always been that way and it's been accepted to be that way. We had one ourselves the other day where the slab's not right and everybody said, well, you got to fix the framing. So, well, why do we have to fix the framing? Fix the slab. Well,
Yeah.
it's expensive. So, but who bearing the cost? Someone's got to bear the cost somewhere. Get it right first time. Even if it's more expensive to do it right first time, it's actually cheaper on the end building.
Yeah, exactly. And I love that example you used about the CLT, the mass timber building, asking you guys to come and put up steel stud walls. That's fantastic. I fully agree. Steel stud is the way to go. It's really a great thing. And when people start talking to me about manufacturing and the manufacturability and tolerances and so on, I say, steel is really the perfect material for this type of industry because like you said, you can make this precise to half a millimeter.
Yeah,
Um,
there's going to see lots more hybrid buildings over as it
yeah,
goes along because it's using the right materials for the right things.
sure.
And I can understand you've got a CLT plant or you've got a steel framing plant. You want to do everything yourself, but it doesn't always make sense.
Yeah,
And it's a matter of picking the right product for the right job.
yeah,
And I'm always happy to sell more machines, but at the same point, there's no point in people building bad buildings.
of course, of course. I mean, steel is a medium though. You see a lot of benefit over traditional timber.
Yeah, so the quality of timber and the quality of steel over the years has changed quite a bit. So the steel has a few things on its side is the fact that it's recyclable and it's very accurate. The challenge we have is converting older builders that are used to timber and they can cut and modify on site pretty easily. And that falls into that kind of lost category that doesn't really get accommodated in the costing. But again, it's the right sort of thing for the right job. You're not going to see a massive, big custom homes built out of steel because the design content in them gets very high very quickly versus
Mhm.
your traditional builder building those sorts of buildings is not used to steel. But we are seeing conversions, especially in the commercial space, especially in the modular space. Everybody's trying to get away from processes like welding if they can, because just the cost of having certified welders and the staffing for those sorts of projects is very hard. Still, there's a place for it, and
Yeah,
we still put hot rolled and welded beams into some buildings. But again, it's that horses for courses thing. Volume stuff. If we want to build lots of low cost, fast built houses, steel's really good for that.
sure, sure. So you see definitely a big future for steel and roll forming within the single family home space.
Yes, yeah, and across the board too. Like in Ireland, there's a lot of schools being done, and they're all
Sure.
modular. So they're going steel floors with steel walls. Um, so there's lots of opportunities there for people to get into steel. The biggest challenge is that you can't set up a steel framing factory and then do everything for everybody. You kind of have to pick a lane to start with,
Right.
especially when you're starting off. Pick one thing, do it really well before you try and do everything else.
Yeah. Yeah. So that kind of goes to my next question. Companies are always talking about scaling prefab. So what do you think that they're underestimating when they're saying we want to scale prefab?
I think one of the biggest challenges is that on-site piece
Yeah.
because that's so critical. And also, they've got to figure out how they're going to move all these modules and handle them in the factory. And there's so many moving pieces. And it's not an easy thing to get in and change something once you're in that process. If you're building 500 hotel rooms, you've got to have that flow of process. And you're not only dealing like you're dealing with all the trades in one place. You haven't like I put up a structure and then I get some plumbers and some sparkies and get the plasterers out on site. You're not dealing with all these subbies. You're dealing internally. It's the
Yeah.
same people doing similar jobs, but that delivery process is quite different. And as I pointed out before, you've got to get all those first stages right. You've got to go out and verify that the foundations are in the right place, that all the underground services are in the right place, because changing that is near on impossible once you're 3 modules high.
Yeah, absolutely. And I think that's also something that's a bit of a misconception by a lot of people in this industry. Maybe fewer people that are actually doing it versus the people looking on the outside in, is that the planning for, panel erection or site erection, whatever it is, starts, before things are even designed, right? And that planning is what works down flow into the manufacturing because oftentimes the last panel manufactured is going on the pallet has got to be the first panel that's going to be stood up, right? So you have to
Oh,
know
exactly.
how you're going to organize all of this stuff and kind of reverse order it when it starts to go in through the factory. So
Yeah.
yeah,
And I think that's one of the other points too, is there's all this front end loading. So there's actually quite a high cost up front for anyone doing anything off site, where if traditional build, it's all on the back end.
yeah,
So that funding model is always a challenge because you're asking for, I don't need a 10% deposit, I actually need a 50% deposit because 90% of the work's done before we get to site.
yeah, yeah. And I think that's a big problem in the offsite industry is cash flow. We
Yep.
see a lot of companies that are starting up and burning through their cash before they could even get a project up. And we see a
Yeah.
lot of failures happening. And I think that's exactly what you're talking about. It's that cash flow issue. You have to have 50% of that project done before you're starting to collect on that cash for that project in a lot of cases. So having the money in the bank is important when you're starting a factory.
Very much so. And it comes down to the client too. It's working with the right clients. If they understand that and they're willing to have some skin in the game too, that does help. We've done some projects here for infrastructure in New Zealand where the end client has actually bought all the raw materials and they own it. It's stockholded for them, and that helps that project. It means that we can spend the money on the design rather than spending the money getting material in for a project. So those sorts of things, and they've got to be had those discussions really early with the clients so they understand, especially when you get into like infrastructure works and schools and airports and hospitals. The money's allocated. It's just a matter of what's the mechanism to draw down on it so everyone's happy.
Yeah, yeah, yeah. You mentioned front loading. To me, that sounds like, you're talking about software, about that software process, that planning process. Tell me, what gaps are you seeing on the software side? Where can we help?
Yeah, so it falls a little bit to what we talked about standardization. A lot of that stuff can be preloaded. We can know what it is. We can know the pricing for the windows. It all helps with that pricing and stuff. So that comes in two flavors. There's the preloading of your design intent, and there's the preloading of the project. I think the design intent stuff is really important because you can have all these pre-engineered components for modules or panels or houses or whatever you happen to be building, you have to spend the time and the money to get that right first, because that saves all the back end. So you've got that on the software side, and then you've also got on the project. Everybody wants the project drawn before you quote it.
Yeah.
So that's the biggest downfall we see everywhere, and we're even guilty of it ourselves sometimes, because you're trying to work something out. So you spend 3 weeks detailing up a building, and no one gets paid for that. That's all just a sunk cost. Now, if you're lucky, nothing changes and you can reuse that work. So the ability to really quickly knock out a rough design without too much detail in it that can be used for basic costing, that's probably a big advantage we can have with the software.
Yeah.
And again, getting those Revit models right to start with. If you're starting with the right thing at the start, and it's been designed with the intent to be built,
Yeah.
there's a big cost savings there. And you guys see it all the time, and we do too, is someone gives you a model and it may as well be a sketch on a piece of paper, because it's really just been designed to give you an image as a starting point.
Yep.
So that's
Yeah,
the
it's a
thing I
napkin
hate to
sketch.
see.
Yeah.
Exactly. I hate to see the same building drawn 7 times by 7 different people when they could be drawing one building and all collaborating on it. So the MEP guy's got his drawings, the stud wall guy's got his drawings, the window guy's got his own drawings. It's just messy.
Yeah.
So that's probably one of the biggest things it's starting to change. But again, it's that front loading. You've got to spend the money up front, and everybody's got to be on the same page. Everybody's got to be engaged early in the process. You don't want to get to the point where you're ready to roll out your steel walls and you're still negotiating on claddings and windows and things like that. It's because they all have effects.
Yep. There's an impact there. Absolutely. So more on the software topic, I have to mention it. AI.
Yep.
How do you think it's going to impact us and what we do?
I think it's going to be a tool like all other tools.
Yeah.
And it's going to have its uses, and it's going to have things that it's not good at as well. One of the things it's already showing is it's very good at compiling data and databases and information. And if you need to find out window schedules or local rules and that sort of things, it's very good at finding those. Still, again, grain of salt. You've got to trust that it's right, and you've got to double check it. I'm not seeing anything in the space of the generative design side of things directly relating to our framing or our machines. It may come, but again, at the moment, a person is still better at thinking through that process and understanding why you do things. What about you guys? What are you seeing on that AI space?
It's an interesting topic, and I see, obviously first phase, you're getting a lot of kind of contextual help and that sort of thing. And like you said, that's about kind of crawling the internet and compiling a lot of data very quickly and, spitting out the best answers. And I think that is tremendously helpful, when you can go through something or feed, AI a lot of historical data, so that you have, basically a help chatbot, which is able to kind of direct you in the right way for that piece of software that you're working. And these are very, first phase, early phase kinds of things. I think down the line, this is quite interesting, because if you think back to the 90s and even to AutoCAD, the UI was very much prompt based. And I think we're going back to prompt based UIs. I think the difference is that we won't have to pay as close attention to syntax in those prompts. You don't have to get everything 100% correct for it to make it happen. I think you're going to be able to, spoken language kind of get it to do what you want. But you're right. As far as this generative AI thing is concerned, I don't think we're there yet. I think a lot of it is still very conceptual. I don't think that we're at a point that, we can really put rubber to road on and start manufacturing or even building, forget manufacturing, just traditional building off of AI just yet. To be seen. But I do think it's a fantastic tool.
Do you think it's going to turn into the useful tool for the as-built side of things? That when you've got that model as built and you want to manage that facility, do you see that becoming a big piece of it?
Huge, because those as-builts are all about data. You know what I mean? So it's going to help you kind of manage that data a lot better, a lot faster. I really think that that's going to be the main thing. I'm very excited to see it in manufacturing though, because I can think of a lot of kind of like process work that AI could potentially do. And I think that's going to be interesting to see kind of like how that plays out. Yeah. So maybe away from AI, stop talking about these damn computers. What's one misconception about the offsite industry that you kind of want to see disappear?
We've always pushed that it's faster and it's cheaper, but it's not actually only that. In some cases, it's not that. Some cases, it's more expensive.
Yeah.
But it's actually sometimes it's actually better. It's a better building because it's a more controlled environment. And also, everyone thinks offsite, they think boxes. It's not always boxes. It's got to be a mixture of panels and boxes and components and individual little pieces. Everybody thinks they've seen those modules on the videos of a big box coming in, being dropped down, and it's away and working. But behind the scenes, there's a whole lot of stuff going on that you just don't see.
Oh yeah. Absolutely. Absolutely. Um, so what are you most optimistic about right now in offsite?
Yeah, so we're seeing a huge amount of people looking at investing into automation for the downstream process.
Yeah.
So we've got quite a few projects on at the moment where we're looking at how do we, just handling pieces. How do we make it easier to make it the building be built with less people because there are less people in the trades, and those again are going to be a slowly approach because every problem you solve, you create the next one. And we've got to remember that a human is really good at figuring out how things go together, and chucking a robot at it is not necessarily the best way. We've just completed a project making a box beam where we've made a clipping system that gets rid of the welding. So you get rid of those welders, they can go off and do other stuff in the factory. You get rid of the fumes, you get rid of all the having to recoat the burnt galvanizing, and the whole process of that we actually did mechanically. So everything is pushed and pulled and moved to make the two components, box them together, clip them together, and push them out the other end, ready for a fork truck to take them away. Um, Keeping it simple is actually really complex. We could have thrown gantries and cranes and robots at it, and it would have cost 10 times as much, and it would look really
Mhm.
cool. But we've made something really simple that it does its process. These guys wanted a box beam for a specific use, and that's what it makes all day, every day. So if you go automation, you lose a bit of flexibility, or you can keep the flexibility. So using this example again, we had a setup that you can run it automatic, or you can run it in a manual mode if you want to run odd components for certain things. But we're very defined, and if it's an automatic, this is what it makes, and it doesn't make anything else when you're doing that automatic process, because as soon as you bring that compromise in, everything goes wrong. And we're talking of stuff like zero point 0.1, 0.2 millimeter accuracy to make it work.
Right.
So a bit like the car industry stuff, you make the one thing. You change the color and you change a few bits and pieces, but you don't change the structure underneath significantly.
Right back to productization.
Exactly. And there's a lot of this going on. There's a lot of people who've got some big dreams and some big ambitions for these huge plants,
Yeah.
and it'll be cool to see some of them take off, but they have to be done slowly and staged. The assembly of the frames themselves with robots is proving really difficult because the frames, because they're not standard, vary so much. We might have, in a 10-story building, there might be, 100,000 combinations. To program each one of those combinations in the robot and then tell them how to handle the piece, how to twist the piece of steel, how to align the holes. We're going to see some technology change. We're going to go away from tech screws and nailing and to other processes.
Sure.
And we're working on quite a few sort of fairly early stage ones at the moment to allow a robot to assemble a frame. But that changes other things because it changes the building structure. So then you've
Right.
got the engineering challenges, and then you've got the design challenges, and it's not an overnight thing that's going to happen.
Yeah, and there's also a cost benefit aspect of this to weigh because, from a lot of the process we see, and we deal with things from the timber side of the business all the way to LGS, and we've seen different companies try to apply robots in different ways. Oftentimes, they're not much faster than human beings,
No.
right? And I think that's something that needs to be looked at a little bit more. Everybody's talking about automation, 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 but in a lot of places still today, it's cheaper and faster, to do a lot of, like, for instance, this frame building aspect of it. Especially when they have a system like a Howick machine where everything is cut exactly to length, right? All you're doing is kind of snapping it together and screwing it. It's a lot faster for people to do that than often machines because there's a process for a machine to make that happen, right?
Yeah.
And I
And
remember, I
Karen,
was just yeah, I was just gonna say I remember when we did, the building that we built on the Autodesk University show floor, right? I remember having to tell these guys because we got the guys from KHS&S, right, who are framers, to come in and build those walls. And we just tell them to slow down. I think we were running the machine at only like what, 25, 50% in that range.
something like that. Yeah. Yeah, we could have knocked out that building in half an hour, but we had to drag it out over 3 days for the show. Um, and I think that's a loops back to the AI a bit with vision and things there, is we're going to be able to see those learning processes and what people actually do and try and replicate them. The other thing you've got to remember with those robots is, we're dealing with really big components. So
Yeah.
you're dealing with really big robots. Sorry, that's the server beeping in the background. So these big robots and things are handling big components, so they go slow. And the
Yeah.
accuracy goes out. As soon as the reach goes further, the robots slow down.
Yeah, absolutely. And it's see
I might have to deal with
it,
that.
it knows that you're talking about,
Yeah,
robots.
there we go. There we go. Stop now. It's not happy.
Yeah, exactly. Stop talking trash about my people.
Yeah.
uh, no, very good. Um, yeah, so I mean, it's an interesting perspective, and I think it's something that a lot of people overlook when you're looking at, manufacturing per se. Like, look at your location, look at what that job industry is about, and see if simply by changing process or modifying process inside of a factory, if it ends up being cheaper to manufacture using people versus trying to push for automation. Because I'm sure you could tell us more than anybody, a lot of that automation hasn't been developed, and it isn't something that's productized yet, right? It's very, very custom right from the software perspective all the way out to the machine perspective, I'm sure. So there's a high cost to start that up and to stand it up and to teach it and to get it moving to a point where you're able to produce with it day in, day out. And I think
And
a
it's a
lot of
constant volume too. That's the other challenge, is you look at people doing big manufacturing plants, they're generally fairly high volume products. Whether it's making toilet rolls or it's making cars or posters and things like that. Sorry, well, video's just stopped, but the way those things work is really important, that you have to have the volume to make the process work. And that's where the modular guys get into trouble, because it's stop start, it's feast and famine. You might have a huge job one week and then nothing for 3 months. And what do you do with all that investment in those people? If it's not built to be flexible, which most of them aren't that flexible, you can't just switch from doing bathroom pods to classrooms or to houses. It's not a process that happens that quickly and easily.
For sure, for sure. And we see a lot of that too. It's another reason why we see a lot of these offsite startups, cruise really high and then they don't end up, succeeding because they don't have that pipeline of business behind them. And that's an old school problem. I don't think that, any AI or software hardware is going to change, business development and pipeline and sales ultimately is where it comes down to.
Yeah, and I'd say probably a key point to that too is, anyone considering setting up any of these plants or going down that automation path, talk to people like ourselves. What are the pitfalls we see, and what are the really, I wouldn't say they're stupid mistakes, but they're the unseen mistakes that just, you don't pick up until it's too late. Because just from experience, we can probably sit down with most people and say, okay, what are you trying to do? Okay, we don't fit, they might fit, or okay, have you considered changing this thing? Because there's a whole lot of people trying to go for, we want to have a patentable system, or we want it to be something unique,
Hmm.
but it may not be the right way. You put the uniqueness where it makes sense
Yeah.
and use standardized stuff. A huge one we see all the time, especially in the schoolroom place. They want to do floor joists, and then they want to go, mostly it's 12 inch, and it's say 12 gauge. They want to go to 10 gauge and a 20-inch joist in the same machine. So you kind of can do it, but you compromise your core business. You're better just to buy that product in from someone else, or use a different product for that particular piece. You get this blind spot and this kind of, I must do everything myself.
Yep. Yeah. And what's crazy about it too is that, a lot of times they haven't thought out the piece that they're thinking about is actually the actual physical manufacturing of it. What they aren't thinking about is necessarily, okay, well, how am I going to get this data to the machine in order to produce it? And we see that a lot. I don't see it so much with Howick, but I see with a lot of other machine types and manufacturers, especially on the timber side, where, companies are buying these making these massive investments into machinery, have no idea how they're going to run those machines and how they're going to feed the machines data, right? And it's the same thing with this. People are laser focused on their secret sauce, I like to call it, and that one piece that's going to differentiate them from everybody else, but they haven't figured out how they're going to actually kind of, send that information to the machine, and it's a complete afterthought. And maybe it's because the software industry, everybody believes that software, should be able to do everything at this stage in the game, with AI and everything else, but it doesn't actually work like that. We have to put a little bit of, forethought into it and plan out that process from A to Z. Good stuff. So, I mean, on that note, I mean, how do you see the relationship between software and manufacturing kind of evolving?
Yeah, so that relationship is very important. And again, it was one of the things we made that decision early on with our machine control file to leave it open language. So it's a CSV, anyone can read it. It's positions and tool names, and that allows us to then work very quickly with, when we get a problem. Is it our problem or is it a software problem? And it's not a blame thing. It's okay, who's going to be in there to fix it first? And quite often we can open up a file and, say we said move 4 inches and the machine moved 5 inches. Well, definitely machine system. If it says move 5 inches and the machine moved 5 inches, but it was supposed to move 4, it's either in the design or it's in the software somewhere. So we can really quickly identify and fix that problem, even to the point you can fix it on the shop floor if you want to go and have a play with a notepad, sort of app. But that piece around how do we figure things out? So, say someone wants to draw something really funky, a new connection detail, we can hand code a piece up, figure out
Yeah.
how that hand coding works, and then we can talk to you guys and say, how do we implement this? And you can come back and say, well, that doesn't work. We can do it this way. So it speeds that process up. As soon as everybody locks everything down and it's all secret, it makes that process hard.
Yeah.
And what we're sort of starting to see is, again, that pre-engineering piece. We want to work with you guys to things like the telescopic wall, for great example. We worked on the process of how that works, and then we make it basically available to anybody who wants to use those machines. So it means we can kind of collectively develop things. So the cost of doing this on a customer by customer basis is huge, but the cost of doing it out to everybody who wants to use it, it's a lot more manageable.
Hmm.
And you still get the customer who says, okay, I want this special extra thing added. So that's a unique development, but trying to keep those cores the same, very important. I remember we looked at a process to work with an ERP system a little while ago, and they wanted a 7-figure contingency on a $300,000 job, because we just don't know how it's going to work, and we've never done this before. It's okay, but what are the important things? Let's get back to the real core of it, and it becomes a small job, and we can add to it in the future. So it's a constant kind of learning process, and it's a constant development. And we're great with you guys that we talk direct to the developers and the teams, and everybody's got a really good relationship there. So we haven't found anything yet that I know of that's a hard no, we can't do it. There's a few
Right.
challenges,
Yeah.
but
Yeah.
generally we can do most things.
Yeah, yeah, I think so. I mean, in software, it's pretty fun to have that answer most of the time. There aren't too many roadblocks. It's usually, yeah, it's possible, but it's going to take this much time or money.
Yeah.
That's what it comes down to. But no, I agree. So we're running short on time, Nick. One question for you left, which is what's next for Howitt? What's up and coming? What's new? What can we get excited about?
Yeah, so we're actually moving site. So we've got our old site and how we've been for 48 years. We're moving hopefully fairly shortly. We're going through the process of getting the building finished off, which is going to be 4 times the size with a whole large acreage of land around the outside of it. So that's going to open up for us the ability to build some structures, do some destructive testing. So we'll speed that process up quite a lot. So there's that happening, but there's also a lot in the automation and handling side going on too, because more and more people want that. But
Hmm.
what we're trying to do is take our usual approach of stand back as let's do the minimum that we can to make the most value. And let's try and stop the craziness of like some of the screw gun technology and stuff you're going to need is going to be a lot harder than what people think a person with a screw gun is. So we're going to take our time and we're working with customers and people in the industry as well around how can we do some of these little things. We're doing a lot with the MEP side of things with our strut machines.
Right. Yeah, I saw that.
Again, taking that process of back-to-back strut, where the traditional way of doing it is you get the two pieces of strut and you weld them together, then you hot dip galv them. So we're working with a self-piercing rivet technology out of the auto industry. So we can actually use a heavy galvanized coil.
Yeah.
So basically the same as a hot dip galv for performance. Bring the two pieces together and automatically rivet them together. We can punch all the holes like we do with the framing machines. So we're sort of the construction industry is changing a bit where everybody was buying lengths and cutting stuff, which is where the stud industry was 20 years ago.
Sure.
Now we're getting cut to length. So like all these data centers, they've got a lot of repetition in them, a lot of the hangers, a lot of the brackets, a lot of the seismic brackets, if you're going into seismic areas, they're all controlled. They all come out of a piece of software. So we're now sort of looking again, take that same process and do it with that. We do a lot of top hat battens, angles, the bracing elements for timber frame buildings, the little angles with all the holes in them.
Yep.
All of those components that you buy in lengths and cut can be rolled in a machine, and some of them are pretty cost effective, especially if you've got a bit of volume. So, and that sort of leads back to the software development of, at the moment we draw the panel. Why don't we draw the ceiling battens and the roof battens, and they come as a kit as well?
Yeah.
We've got a customer here in New Zealand that does that. He does all the ceiling battens on a room by room packet based out of the machine, all cut to the right sizes, all labeled where they go. He can even pre-punch into the framing the screw holes if he wants. That's where I see it moving. The early adopters are now onto the next phase, and the rest of the industry is following along slowly.
Yep. Yeah. I mean, it's moving a lot faster than it was, 10, 15 years ago when we
Yeah.
first started talking to each other. That's for
Right.
sure.
And there's so many more people now that understand the software and have sort of grown up with it. So we're getting that changing of the guard as well. There's people leaving the
Yeah.
industry because they're sort of aging out of it, and a
Yep.
lot of young people coming in. I think the biggest challenge is the very young school leavers at the moment and the university leavers is keeping them engaged because AI is such a hype at the moment. You still have to have the skills. You still need the learning to understand what the AI is
Absolutely.
doing.
Absolutely. 100%. Well, Nick, we are out of time, but we are going to be seeing each other again pretty soon at the National Association for Home Builders International Builder Show in Orange County, Florida, or sorry, in Orlando, Florida at Orange County Convention Center. So that's on February 17th and 19th. So if anybody wants to come and bug Nick about, some machines, ask, some questions to either of us. We'll both be there. We'll be at booth S11209 for anybody interested. And I think we've been flashing up over the screen while we've been having this chat some contact information. We will end it out with some more contact information. Nick, big thanks for joining me on this. It was a pleasure as always to speak with you. I owe you a drink and a steak next time we see each other.
Thanks for having me. It's always good to have a chat about what's going on in the industry.
Absolutely. All right. Thanks, Nick.
Thanks.
Bye-bye.
All right. Thank you so much, Brandon and Nick. As Brandon mentioned, you can find the team at the International Builders Show in 2 weeks from now, February 17th to the 19th. They will be on booth with the Howick team, booth number S11209. All right. Just before we end the session, I'd just like to say a big thank you to Nick and to Brandon and also to everyone who tuned in for this session. After the session is completed, you'll actually be able to find the full video on demand if you choose to. All right. That is it for me. Have a great day, everyone.